right. Welcome, everyone.
What's happening?
What is the happening? No, I don't mean to I'm not asking about the movie The Happening. Don't tell me what that is.
Don't think I've seen that.
I have not either. That's fine. I'm okay with that. I'm all right with that. I've made my peace with that. We've got Ha Ha By Now in the chat. Yeah, so this was very last minute.
Well,
what?
I was going to ask, what's so special about this week?
Yeah, so this week, according to Eric, which I have not verified, so he's probably right. Eric's
Let me re-verify
right.
this. I'm going to go to your channel.
My YouTube channel.
And scroll down.
Yeah, this is
episode.
This is like an anniversary week.
It's the 1 year anniversary.
It's been a year since we started the Tech Audio Chat, and it's been a wild ride.
Yeah, April 17th was
April 17th. All right,
the first one.
Hey,
back before the days of the there was no background. It was just a black background behind us. And
well, that's because we started out trying to use Zoom. Hey, Pilar.
Times have changed.
Yeah. The first few episodes we tried a bunch of different. I think it was like a few different configurations. Some of them got really complicated. But yeah, I think Zoom was one of the first ones we tried out. Yeah. But I like the platform we got. I mean, I think this is cool. It's got some bells and whistles, and it's kind of fun, and it's not too expensive for a year.
Seems like it makes it easy to just hop on and start.
Yeah.
But you're going to have to renew that subscription pretty soon, probably.
It's going to come up here. Yeah, exactly. Yeah, so technically it hasn't been a year. We're a day short. A day short.
We could have a separate one tomorrow.
That's right. No, this is good. This is so. I think this is this is episode 32, and that tells me that we have had a more than 50% success rate in having a show. Hey, Clara. And so I think that says something.
It's a 62%. Success rate, I guess, or
I mean, I guess it depends on if you intend to, do shows during holidays or something like that.
Rain or shine every day. Out there,
every week. That has not rain or shine has not been the situation for us. We're not that consistent. But it's not bad, and honestly, I don't know if it's even. Sometimes I'm not even 100% sure. Every week works for everyone.
Well, it's been nice having an assortment of guests to kind of fill in for me if I'm not available, or I mean, you're pretty hard to fill in for on your stream, so
that's true. Whenever I'm not available, that's tough cookies. But yeah, I agree. It's pretty awesome. We've had a lot of really cool people on the chat over the last year. That seems like a something a dedicated streamer would do, like an anniversary celebration video. Seems like it.
Well, I mean, since it's the first time having an anniversary, we can cut you some slack for having a delayed celebration video, or maybe we could do a special episode coming up or something. Maybe like episode 50.
Episode.
Episode 50 could be like a milestone, or I don't know.
That's true. Yeah, I also a year in, and I have a much more flexible schedule these days. So I've I've also thought about maybe there's a better time for everyone. Thursday just kind of seemed like it just seemed like it worked with my schedule. So I don't know. Yeah.
Shake it up.
Yeah, it could be that. Different formats. I don't know. There aren't any rules. It's
just
the
don't
Wild
play
West
copyrighted
here.
music. That's the only
Actually, that's a big one. That's
the one rule on the stream.
I've had 2 copyright strikes on my chat, and they are both the times when Aaron has joined the chat. He just can't help himself from playing copyrighted music.
It was like 5 seconds of like a clip too, and it was
it's 5 seconds of giant steps. And honestly, you could have just hummed it,
I wonder if that gets flagged as well.
Maybe.
Gotta be careful. You can't.
Yeah, they would never catch me. I have such poor tonality.
Just have to improvise a little bit to put your own spin on it.
I'm on top of it. I've heard of jazz. Yeah, so these days it's been I have been busy with trying to trying to figure out what the thing is, what do I do next?
Mm-hmm.
It's there's a little bit of the, hey, I have to get a job because I need to survive. And I enjoy a lot of things right now, literally things, and I don't want to have to sell them off, including my house. So there is a kind of motivation to replace the paycheck with paycheck. But there's also kind of a little bit of a freedom here. Like at Epic, I was motivated to constrain my job responsibilities because Epic has a very aggressive non-compete clause, and so I was very careful not to do things. First of all, not to put stuff out there that Epic could construe as part of my job. And also, I tried to avoid things that could be legally compromised by my employment, which includes not making music,
because there might be like an ownership claim sort of thing.
Yeah. And I didn't want to mess around with that. They've got more powerful lawyers than I do. So there's kind of it's kind of fun to think about making music again and doing sound design again. I did do some sound design at Epic. But here's the thing is there is somewhat of a supply and demand thing when it comes to technical skills, so-called technical skills, which we're really just talking about like engine skills, which is a lot what we do on this chat. There are just fewer people who are interested or motivated to learn that stuff. Sometimes it's really hard. There's, very early humps they have to overcome to get into it. And that can dissuade people who just want to make some sounds or music. And that's totally understandable. I totally understand that. But it does mean that there are fewer people doing tech audio than there are not. And being a good tech audio designer also does mean that you have to know what sounds good. And it helps a lot if you understand music theory, especially if you're going to do any kind of music design. So it's not that it's an add-on. It's the way you should look at it. You don't necessarily need to be like the best composer or music producer. You don't necessarily have to be the best sound designer. It can be a great privilege to work with incredible sound designers and composers as a tech designer, but you have to understand that stuff. You do have to be competent in that stuff. And so the tech work is an add-on, and there's just fewer people who are adding that on than there are not. And so, it was very easy for Epic or me to look at my time on any given project. There were a bunch of special projects where I kind of determined my own what I should be working on. A lot of autonomy, special projects, a lot of the sample project stuff, and so it just made more sense oftentimes for me to do tech audio work than not, and just to have someone else do the non-implementation, non-engine.
Someone
stuff.
Working alongside you to...
Yeah, exactly. And that's a privilege thing, because Epic has had the money to do that. They had 20% more than they do now. But or rather, I should say, would that be 20%? It'd be like 18%. Anyway, it's
math.
The percentage offset. Anyway, so obviously, that's a privilege. A lot of folks working on smaller games, AA games. A lot of colleagues in this industry are like soloing, or they're the only in-house person. They're working with contractors for these sort of one-offs or like short duration bursts. And again, they're probably in a very similar situation where they're going to have to spend a lot more time on the implementation side of things, because there's a lot of work to do there.
Yeah.
And sort of rely on, contract work or someone else, and it's just going to be easier to find those folks. So.
Yeah, one thing. So back when I was actually starting to get into doing tech audio, I saw it as, well, not only like a pandemic hobby, like everyone's making sourdough, I'm here learning Unreal. I saw it as like another like tool on my tool belt, 'cause
Yeah.
I was into music, and so I was doing like the whole composer thing and music orchestration, production stuff. And so I saw increasing my technical skills as like another way to find opportunities. And then I just kind of fell head over heels into everything about designing tech. And since I started at Epic, I actually haven't been doing any music work, just because I've been enjoying doing designing systems and learning how to program and all that stuff.
Yeah, I felt like it was very similar for me in terms of like my goals. I think it's really important, even when you're working for a company or a studio, you should have your own goals, whether they're career oriented or even just sort of project by project. I would oftentimes sort of roll in something I didn't have to do because I want to learn more about that thing. Yeah. And that was definitely an objective for me, was sort of improving my programming skills. And it was a great opportunity, I felt, because there were I had so many near team colleagues who were just really awesome programmers. And so it was, like what a wonderful opportunity for feedback from people who know. It can also be intimidating, though, I think, when you're in that sort of growth mode. You do some dumb stuff, and it could be like, I don't know if I want to show them yet.
I definitely feel that way.
I mean, I feel I've looked at your code. I think it looks great, but
well,
take that for what it means. I don't know what that means.
I appreciate it that someone out there has nice things to say about it.
There's been, I think, one of the most interesting aspects of, and I don't know if you've experienced this yet, like trying to find solutions for these real world problems, because that's part of it, right? That's kind of the fun of it, is like you're presented with these real world problems and you're like, how would I do this as a programmer? And what I found really oddly validating is coming up with a solution that already exists. Where it's like, oh, what if I did this thing, but I did it like this? And then it's like, oh, that's this thing, and that was written in a paper in like 1978. Like,
yeah.
And so this well-established, computer science concept, but I'm only just now discovering it through my own like methodology. But it is weirdly validating. It's like, oh, someone had that thought before. That's great.
I could see that. Like, my assumption is that I'm not coming up with like unique original things that haven't been programmed before. I just assume someone out there has done it before, and I try and find it, and then ideally if it's in the engine or on GitHub somewhere, I can look at it and study it, but don't have to read white papers for everything. But I've done the white paper thing too, and it's fun because it's like a good exercise, to implement some math equations or something that are
some classic data structure or whatever.
I think it's good for experience, but as now, like I'm maturing more, I guess, as a programmer. It's like you start to kind of get a spidey sense when things aren't easy. You kind of know you're probably heading in the right direction, and that's when you should stop and like look around and find the easy path that's already been done before, and try and redirect yourself. But
it can be difficult. I know that in Unreal, there's a lot of useful code that is private in some module, right? Like it's just, it was just some one-off, for some team, and then they didn't think about like making it generic or whatever.
Definitely run into that sometimes, or even when I'm making my own system, it's like I always try and weigh like, oh, should this be private, or should I expose it public?
Right.
And conventional wisdom says to keep things private until you need to expose it. So I'm sure it's just a lot of kind of following that conventional wisdom to keep things kind of guardrailed a bit more. But when you're developing on a system or a feature that you want to have extended and stuff like that, that should be one of the the first things that you figure out for real, instead of putting that off till later and then shipping it private and someone's like stuck.
Yeah.
But.
Yeah. Some of it is thinking about the shared team resources. Mm-hmm. There's a lot of redundancy because people aren't talking to each other.
It's not a real feature until there's at least 3 competing versions of it in the engine.
Well, this is a good segue to one of the things. Well, actually, I think is a good story for chooser tables. We're going to talk about chooser tables with the caveat that it's been a long time since I messed around with them. So if Mitchell ever sees this stream, he'll just be incensed. That's an inside joke to someone who is a huge fan of chooser tables.
And there's a lot of them out there. I don't have experience working with chooser tables, but my exposure to what I know about them has been kind of forced upon me by what I would refer to as chooser table evangelists. And basically, once you spend enough time with chooser tables, I don't know how long it takes to become an evangelist, but it happens to everyone who uses them, and you just can't stop telling your coworkers about it.
Well, I think the story is good because it is a situation where the animation team made a feature specifically for animation that had clear general utility. Mm-hmm. And there was a kind of demand from other teams who saw it to be like, hey, we want those. And so then they did the good work to make them just generically available to folks. And that's the same thing with State Tree. State Tree was made by the AI team, made for AI, and obviously state machines are really important in game development generally.
That's why you got to check on your other teams and see how they're doing things, because you might be able to steal some of their tech or copy their notes or something.
Yeah.
Yeah.
Clara is a fan of chooser tables. Okay, yeah, Clara. Yeah, so Clara, you can correct us.
Yeah.
When I make a mistake. Shall I pull up the premise? Let's see what.
Yeah. Do you want to start off with what are chooser tables, or when or why would you ever consider using them?
I think.
I mean, maybe you want to jump into it.
I think that let's first of all, chooser tables are a plugin, and the plugin is not on by default, so you have to activate the plugin. And so if you look at here's a little project. If you look at I have the plugins window open already. Cool. So if you just search for chooser, you'll
chooser
see
plugin.
You see the chooser plugin, and this gives you the chooser and proxy tables. And so, the base use case is if you want to make a selection based on a set of criteria. And the selection it's more easily an asset type. It sort of leans in that direction. So
can you phrase that again? Sorry.
Let's say. So it's basically a more robust version of a lookup table. Really just sort of deep.
So let's say you have something that you're trying to select. Maybe you have an enemy class and you don't know which class of enemy you want to spawn there. Yeah. But maybe depending on the time of day and the biome and your level and stuff, like all of those things kind of combine, and you can boil that down into like a selected actor, right?
Yeah. So think about it. So one of the challenges that we have in audio, this is actually almost specifically an audio issue, is that we're very behind the curve in terms of modeling. And so a lot of what we have to do in audio is to interpret. We have to go through like an interpretation process. So for example, let's say you've got a bunch of physics stuff happening. We have to switch which sound we're playing based on, let's say you've got like it's sort of classic is like a cylinder. So you got a cylinder, you could roll it, you could drag it on the side, you could drag it on its end, you could like swivel it on its rim, like all those sound different. Mm-hmm. And then you have materials and you have all this sort of stuff, right? So all this sort of criteria come together, and in other domains don't understand our pain because they're simulating. They're running a simulation, and the simulation includes a model for the material or the the gravity or the like two bodies colliding. All this sort of stuff is simulated.
PBR.
Yeah, exactly. PBR. That's an interesting one because that's more hybrid.
Sure.
Because you can have textures. But like, physics could deform the mesh. Like all this sort of stuff can be modeled. But in our case, we have to swap out sounds, right? Which is very frustrating. Like, and then we don't get any guidance there. Like someone here, I have 1,000,000 newtons of impulse. What do I do? Like, what does that sound like? So so it's not very useful. And we have to do this, and that to top it off, all the sort of the like, it's a simulation, but on top of that, it's also tweaked. All the values are tweaked. All the thresholds are tweaked by game designers because it looks cooler.
Yeah.
And so we're not even getting reality. Like we get 1,000,000 newtons, and then we're like, this would never happen. It would like dent the sidewalk, or something. And so like we have to sort of look at the data. This has happened so often. A lot of like physics stuff, for example, is looking at the data and then finding our thresholds and going, okay, well, once we're over this, we have to switch to this sound, or we blend between these two sounds, or something like that. And so, if you were to, and this is the sort of simple example I'm going to give here, footsteps, the canonical, like, we got to change the sound example. And you've got, material. You basically have like in this case, it's gonna be a simple matrix, which is your footwear and the surface, and those are 2 dimensions. And so, in order to switch between 2 dimensions, right, you basically have to represent that as a table. The more dimensions that you add, the more complex the process to look up. And if you just have a data table, like literally just like an Excel spreadsheet or something like that, then you have to write something that like, looks this column up for this value, and then looks for this value in this column, and looks for this value on this column. Mm-hmm. And that's just matching values. And so the chooser table is like a more robust method of going through that lookup process. It kind of automates the lookup process. And so, let me see. And so the output, the sort of default approach output for a chooser table is...
Can you enlarge the...
Yeah, I will. Just a second. Chooser. So... once you have the plugin activated, then
they put it in both places.
They put it in both places. It's smart. So, okay. So in our case, we want a generic chooser, but this basically we're just going to create a generic table, and we'll basically want it to output a asset reference. So we want to select an asset, or sound asset in this case, based on a bunch of criteria.
But you could select any type you want, right? If you wanted a bool or a float or something, like that's something you could output.
Yes, but I'm pretty sure, Clara, you can correct me, and we can just look at it. But you'll see here is it really wants to give you an object.
Okay.
But you can do, so it's object of type or a subclass of is like what it wants to output.
Sure.
And so that it makes it easier if we're like, I'm just looking for a sound base or something like that, then I can be like, it'll output a sound base.
Mm-hmm. I suppose you could do like a struct type that has your data packed into it if you wanted that.
So
like an instance struct sort of thing? Maybe not.
Yeah, it really wants an object, but it could be like a data blueprint, right?
Mm-hmm. Yeah.
Yeah, Claire is trying to remember also. I think you can do it if it's like, oh, I've got a blueprint class, which is an object, right? And so, and then I think that you might go with a subclass. Yeah, or if you want to, I guess if you could select a specific blueprint. But in our case, we can just select a sound base or a meta sound or something like that. And we'll call it chooser table. Chooser table. And we'll just do a little test. We'll just take a look at it. We just want to take a look at what's going on here. Okay. So I'm opening it up. Boop. And you have over on the right side are all the stuff that we sort of designated at the beginning on the sort of wizard that we got. Yeah, exactly. Claire has mentioned this. For input, output it wants a result that is going to be an object reference, but for input you get a little bit more flexibility there. Mm-hmm. And the other thing is that chooser tables can also output chooser tables, which is kind of wild to think about.
Inception.
Yeah, so you could have like a chooser table that, like, for example, this was something that I thought about doing this time around, which was like a chooser table that selects, between walk and run, and then a sub table for deciding, that's. But yeah, there's probably other more clever ways to think about that. And then let's see. Yeah, so we have rows and columns. Rows are your results, and a column is your criteria.
It's easy to remember.
Yeah. So so let's add a row, and it's going to be here. Yeah, here we go. An asset soft reference, which is cool. And then it could be another chooser, a nested chooser, evaluate chooser, which is just yeah. Okay. So yeah. It just immediately evaluates the chooser that's selected in this. And then this was what you were talking about before. I think this is something I haven't played around with, which is this a proxy asset entry in a proxy table. Yeah. I don't know what a proxy. I haven't messed around with a proxy table. Maybe Clara has some background on that.
Yeah, I remember someone telling me about they had a proxy set up, and so I'm sure it's useful, but I don't recall what the need for it was.
Yeah. So anyway, here you have the asset types of this object, right? That I selected the sound base. Mm-hmm. So we have all the sounds here. And let's say we get this test ping. And then on the criteria, the column, we can start adding all of this, all these different parameters. And what's cool is we can actually have a reference to an object. So this is where it's got some similarities with state tree. We can bind it to an object, and I think, let's see, we can do. Let me make a quick. Oh, here I'll select my my character. And what is he called? Sorry, demo. Ugh. Sorry, it's this blueprint here. And so I think. Oh. Maybe I'm missing. Oh, I'm misremembering this. Hold on.
Are you trying to access the properties of?
Yeah.
So maybe you have to choose a different type than object, and then you can bind to something on the object.
This is a specific one. I believe. Hold on a second. I've done this before. Welcome to the stream.
I'm trying to be helpful, but I'm working against you here.
I think it's this. Here we go. Class parameter input class. Sorry. Oh, here we go. Input. And then I have my demo character. There we go. So now I have this. I've designated this as a parameter input for the chooser table. And then let me delete. I think.
So before you deleted that, and maybe
there we go. Here it is. Okay. And so here I can find my boot. Did I not make it public? Classic Dan.
We were just talking about this.
Public parameters. Yeah, so here this boot tag is what I want to expose. And so now when I find... do I need to... maybe... Oh, you know what? Sorry. It's because I have object. Oh, hold on a second. Maybe I don't need it to be... I think this should... I was almost there. Maybe I need to poke... Did I poke the... There we go. Object. Bind.
Clara says single tags don't work.
Oh, great. Oh, it's got to be a query. Right? Is that right? I think that's it. Do I need to do it as a container?
Oh, yeah.
That's what she said. Okay.
Yeah, I missed the message just above that. That would have been helpful.
Okay. Yeah, we'll do this. Container. Yeah, that's fine. It'll break things momentarily. Whoops. There we go. This will be... It's gonna be a single container. It's gonna be pretty empty. Remove. Yeah, do this. Some of my logic's gonna have to change here.
It's all good.
Yeah, there we go. Something like that. We don't need to do that, actually. Do something like that. Yeah, there's going to be some fix-up. Okay, so now we've got a... Yeah, there we go.
There we go.
Boots tag. And then if it's a query, then we can just do a classic all tags match. So I have, anyway, so that's so we can also add a column which could be like I think on the so if we have, where's my table settings? Let's add an input, and then here we have structs, and then we could do can we do we might have to make we might have to wrap it, but do we have surface? No. Oh, that was it. Surface. What was it? Physical surface. Oh, name. So I'll have to make a surface, like something to wrap the physical surface enum. But effectively, we could have a surface type evaluated here. Let's do. I think I just make that real quick here. Yeah, okay. We'll just do a new one. I'll use that as like a part of my project name or whatever. Surface. And then we have the physical surface.
So this is like how I was asking before, if you wanted to do like a float or a bool, you would wrap it like this. Okay.
Yeah, well, we designate it as an input. And then the data becomes available. Because what we're going to do is we're going to call an evaluate function on the chooser table. And it will construct a like fancy blueprint node with the proper inputs and outputs. So now we could do an enum to our physical surface. And classic Dan forgot to add the physical surfaces to the project setting. But yeah, so there, there you go. Claire is Claire. I'm missing all of your yeah. So we'll struct it. Yeah. Okay. You can write to a struct output. Yeah. So that's really cool. You can write to the output. But real quick, I wanted to let's just add a. I'm not going to use this. We're going to keep it simple. But I wanted to sort of mention this, and that is. So this is where it can get really interesting because I could do a range value as part of the evaluation. If you had a traditional lookup table, first you'd have to get the value and then do an evaluation on top of that, right? And so in some ways, this, you could be like, oh, I want to select this only when the speed is between, 0 and 300. And so that could be a more interesting or more robust way of indicating, which selections you want. And obviously there's no end to this in terms of like how many columns, well, maybe there is, but I haven't found it. In terms of the columns of criteria you can create.
So once you have your columns set up, your criteria, you can then just start creating results for different combinations of.
Yep. Yeah, exactly. You can just keep adding rows. And here you can have a fallback as well, which is pretty powerful. Nice. And that may be where maybe that's how you just designate your, like what goes on a single chooser table. Like maybe in this case, we fall back to some default surface type, but maybe we use the chooser table, like we split out the different speeds on different chooser tables, right? So maybe we have like, let's say we got walk and run, and so between speed 0 and 300, I want walk. Between 300 and or maybe 301 and whatever, to 400 or 500, whatever.
And that's
maybe I want
more
that
of a organizational thing.
Yeah, exactly. Because then I could have like a fallback default surface, but for run, that's different from walk. Right. So yeah, then you just keep adding your rows, and then in your blueprint, you can call evaluate chooser, and then you'll see this is where I started to describe that's what I meant earlier. We were talking before the stream started where I said it's not dynamic, which is kind of like it's an insufficient description of this particular issue, which is I can't change. This function always has to evaluate. It's this particular chooser table. I can't change which chooser table this function evaluates.
It's kind of
does that make sense? Yeah. And so then here's our inputs, and you can see we have our object ref input, and then we have an actual reference to our struct, which means, as Clara mentioned, it's a reference. So if you have it as a, if we had it as a, where was it? On the table settings, you'll see an option for input output. I think this will. Oh, it does give an output reference. Interesting. So I don't know if it's getting passed in as const or not. Under the hood.
Yeah.
But yeah. So then you'll have. Yeah. So I don't know if this is doing a copy or what is going on there. That might be something to play around with.
Yeah, that's interesting.
Oh yeah, and then here we have return soft object reference. Oh, and this is cool. You could have it return just the first matching result, or all of the matching results, and then you could kind of decide what to do in that case. But yeah, so then you'd call this, and we would pass. What's cool is that we could just pass this and our actor in, and if all of our relevant data is stored on the actor in some way, like in a component or directly as a member parameter, member variable, then it's accessible inside of the chooser table. So that's one of those things where I sort of liken it to state tree, where like the state tree has access to its
context,
its context object or whatever actor. And so in that case, in the chooser table case, it's a little bit more generic. Obviously, we could pass in multiple objects, which is kind of cool.
You could pass in state trees.
So yeah, so that's the gist. Did I miss anything, Clara? Clara, do you want to just join the? You're welcome to. If you want to, you're welcome to. But yeah, that's so okay. So that's the rough gist. How are we on? Okay, we're all right. So this is where I'm a little bit worried that so here's the setup. What I have, and maybe this was a little bit too much to chew to do it live. Oh yeah, I forgot the main character. I messed everything up here. Okay, let's see let's fix this up. So what I have here is I have a player character that spawns here at the player start, and then I have these different surface types: grass and mud, and sort of concrete or rock,
cobble,
yeah, something. And then dirt, and then I have these triggers, these little boxes that have different footwear for my character set up. And what happens is the player character implements an interface, and these sort of footwear givers. Providers do a check for that interface. First of all, it's set up to overlap only pawn, but it checks for the interface, and if the interface is available, then it calls this function update wearable, and it passes its boot tag over. Mm-hmm. And so the boot tag is basically exposed on the instance. You can see it here, and so each boot has its own tag. And then I sort of did like a very simple check to see if this is very like hacky here.
We're not character artists.
We're not. This is. But now I gotta fix this up. Yeah. So. Right. Yeah, actually, now I want to double check Claire's assertion that I can't do a
just a loose gameplay tag.
Yeah. I just want to double check. Because I also had, there were other issues that I was running into because I had not set something up correctly. Yeah. And it's only see, because it's got this one gameplay tag.
Is that not what you want there?
This is
boots tag.
This is a container.
Okay.
Gameplay tag cells pass if the input gameplay tag collection matches the cell data. Oh, right. So the cell data itself. Yeah, so Clara's right. Not that I questioned you, Clara.
Can't you set any? Can't you choose like your boot type there?
Well, what I can do is I could... Oh, I could... Okay. I could swap the interface to pass a container and then just swap out the container and just assume the container's a single entry container and then set the container on the boot's trigger. It's a little hacky. Here's the thing. I'm trying not to use... I wanted to do this all in blueprints. And there's a lot more in the gameplay tag API in C++ than is in blueprints. And so if I wanted to do it with container, because basically what I need is a mutually exclusive container, and that's going to require like a whole string search. Like I have to parse it as a string and then check for Okay. And in the C++ API, you can actually do like give me your parent like namespace. Like you can chunk it up, and it's more easy to check things. Anyway, so what I'll do is I'll hack it. So this is a container, gameplay tag container. We're gonna break a bunch of stuff. We're gonna change our interface to pass containers, and this will be like, again, this is not the thing that I want you to take away. This part is like some gameplay person has set this up, and now you've got to be able to swap out sounds based on changes to like the skin or the footwear or whatever. So that was the idea behind this, and then I will. So this compiles now, and then here we will do what we had before, which is we're setting this, and then calling this. We're getting rid of this vestigial gameplay tag, and then we swap this out with a matches call. Which is basically the same thing that I had before, but with the container. Instead of two tags, it's a container, a tag, and this one will be this, and this one will be this, and double check here. Just so if anyone's curious, what I'm doing here is I actually have all 3 boots on the player character, and I'm just swapping visibility because I didn't want to do like a whole like custom actor child thing where it spawns and
Hey, ship it.
Yeah.
If it works, it works.
So the only thing we need to fix up will be our actual instances, because we got to add a tag. So this one is for the peasant boots. Am I remembering that correctly? Yes. And then this one is the thief boots. And this one is the... And this art is from... Okay. A company on Fab called Enhance.
Nice.
And it's a bunch of stylized character. So here's the idea. I've got this dude. And if I... let's see if check this works. You can see now I've got the same shoe wears I just crossed over. And similarly, if I go over here, I swap to these boots. And then if I go over here, I swap to these sort of armored boots. Okay. Unfortunately, I just have some loose footsteps, and they're not all. Some of them are like add-ons. I would call add-ons, supplemental sounds. Why did I do mud like the character Mud in Star Trek? That's kind of funny.
Hey, whatever works, you know?
Yeah, so this is like some mud add-on, but I feel like it should be sort of added on to some other bass sound. We've got some designed art. This is all from Boom Library, so you can blame them if you don't like the pieces. Some leather add-ons, some grass stuff. So yeah, I basically need a little footstep system. Maybe this is a little... We've got an hour. I guess we could technically go over, but I always get really tired after 2 hours.
Yeah.
I guess we could just see how far we get, and this could be like a part one. Sure. Thanks, Clara, for all your help. Oh, she's already gone. Hey, Steven. Welcome. Yeah, so we're going to build like a little footstep system because I need to detect surfaces, and I need to detect... I need a notify system. So I'm going to... This is something that I've always wanted to do anyway, so this kind of works out, I guess. We're gonna roll our own anim notify.
Doing it live.
We're doing it live. So I'm gonna add a new blueprint class, and I'm gonna open up to all classes, and I'm gonna go anim notify, and you'll see there's a whole bunch of stuff there. So there's two different types of notifies. One is called just an anim notify, and one's called like an anim notify state. And so the notifies are for one-off events. And the state is if you want to have something that sort of is continuous for a set amount of time. So a state could be useful for like a looping or like a sustained element. But in our case, we're just going to keep it simple. We're just going to focus on the footsteps. We're not going to do any other Foley stuff. So we'll create our own custom anim notify. And there's a couple things that I want to do with this anim notify. And that is because there is a sound notify, but it's very old, and it just plays a sound accompanying the frame, execution. And so what we want is basically a notify that's going to do a little bit more work on our behalf. And that includes maybe, we're going to want to evaluate our chooser table. And that may happen. We may want to do that in the notify, or we may want to do that inside the hero, the player character blueprint. It's kind of up to us, because let's take a look. We'll make our own, and you'll kind of see. So we'll start out anim notify, and then we'll call it, our wearable footstep. And when we open it up, we have a few functions that we can override. The main one that we care about is receive notify. So this is the function that's called when you receive the notify. And you'll notice that it gives us a reference to the mesh component that this animation is playing on, I guess you could call it, say. Mm-hmm. We get a reference to the animation sequence. And then we get event reference from this notify. We can add variables to this notify that are settable in the animation. Let's take a look at the other ones. We've got get notify name. So here we could give it like a custom name. We'll just call it like wearable FS or something like that. We'll do that. And then we have this get default trigger weight. And so in our case, the trigger weight's going to be 100%. But that's something in anim notifies also support this sort of probability of the animation notify triggering. And that can be really, a nice way to sort of add a natural playback to your notifies. But in this case, we're just going to set it as 100, or we could pass it as a variable. So we could say, hey, trigger weight. So it could also be some calculated function. Mm-hmm. So if we take a look at our animation, I think we have a reference. Let me check here. This is, if we go here, we can see anim class. There we go. So here's the animation blueprint for this character. Very muscly. Very ripped. And then we actually have a fair number of locomotion. Let me just check here. We've got spells and sprints. Here's our walk. So like here is the walk forward. I think we're actually running. Let me just double check here. What is our character doing here? That looks more like a run to me. This is the walk. So it's probably using this guy. This is a blend space, which blends between two different animations. And this is a 1D blend space. And I think... that's 375. I think it's just this. I think it's just this one here. So yeah, I think so this one, this looks right. This I think is the stuff. Well, we can check. Let me just make some space here. I'm gonna pause the playback. Oh, that's nice. The foot's going below the surface.
It's all those muscles.
It's all those muscles. That's right. That's no joke. So this is the cycle. Looks like it. Yeah. So we got 18 frames total. And this is the notify track space. And so if we want to add a notify, this is where we do it. We could separate them out if we wanted to say multiple tracks. So we could add another track, and we could say like, we could do something like left. And then I think, there we go. Right. So this could be a way to sort of, distinguish where things go. And you'll find that sometimes you just need the notifies happen at like a moment on the timeline, but the notify name sort of, it like sticks out. And so sometimes you just have different tracks for the space, or sometimes you just
to overlap and
sometimes you just organize it that way visually. But also tracks are containers for notifies, and so if you're looking at things like the animod blueprints, or if you're just referencing or doing something specifically with the animation, the animation blueprint itself, like referencing the animation, you can get notifies off of the tracks, and you can sort of do stuff based on that. And so in other words, I could be like, hey, in the animation mod script, I could look at, hey, this animation, and go, give me the left track, and then give me all the notifies on the left track kind of thing, and then I can do stuff. And so this is actually something that I did with Project Lyra. I don't know if I left the mod script. I think I did. I think you could, if you open up Project Lyra, you could probably find this script where I basically went through, because we had, after the exec, like one of the first major exec reviews, they were like, this needs to look cooler. And so they contracted like 4 more animators from like Hardsuit Labs to just add more animations, and I was like, what about me? So I had to write a script that would auto tag the animations.
You can't keep up with 4 other people?
I can't keep up with 4 other people. And then actually what's funny, I think this is what Paul and was it Seth? I don't remember who worked also on that, but on the animation sample project.
Oh yeah.
They also had to use an auto tag system. So anyway, that can also be a reason for separating stuff out into their own track. Anyway, we're just going to add our notify. If we look at the notify list, we can see the like available types, and play sound is sort of like the one that we're used to grabbing. But here, if you can see my like custom type, and you can see that it's given the special name that I gave it, basically. And if we click on it, we can see. Oh, did I forget to make it public? Hold on a second.
Instance editable?
Classic. Okay.
Default category.
Yeah, here it is. Trigger weight. Oh no, that's sorry. That's
your default category at the top of the.
Oh, thank you. There you are. Yeah, trigger weight. So actually, I wonder, does that update? No, okay. I wasn't sure if that was going to update. But yeah, so that's maybe that value is read in once instead of updating.
Sure.
Let's see actually if that is the case. Let's edit this value to 50%, and then let's add a new one. So I just delete it. I hit the delete key. So a fresh one. Yeah, there it is. So maybe that value is only read the first time when you create the instance of the notify. So anyway, we can put whatever we want here, and that's what we will do. We're gonna put this is where I would recommend putting an event abstraction. This is what if you look at Project Lyra, you'll see that in my case on that project, we had a few different locomotion types, and it was, I think we had, there was like there's crouch and run and walk and all this sort of stuff. And so, so you'll see that there are different events. I think I did different events. And so the notify, if you look at the notify, it's just going to have an event tag. I did a gameplay tag. So you can say, hey, this is the event that's playing. So it could be like, it's a run, or it's a walk, or it's like some other event. Like it could be, a fully whoosh or something like that. And then that just becomes an event that you communicate downstream. And then in our case, instead of playing a sound at this stage, we're going to be, calling an event. Anyway, I sort of mentioned that because this is where the data can get really interesting. Because you can sort of, like, for example, let's say you're like, oh, I want a whoosh sound that plays for 30 seconds or, half a second or a third of a second. And so you could say, okay, here's the event tag. It's a whoosh. And then here's the time it needs to take. And then, you could have some downstream procedural system that maybe a meta sound that's like, okay, we're going to play a whoosh. Let's play the whoosh the meta sound whoosh. And then the time that the whoosh has to take is this 0.3 seconds or something like that. And so you can create really cool stuff. And this is all just blueprints, by the way. I think that's really important to sort of point out. Is that you can actually do a lot with your own custom notifies. So if you're starting a I think the sound notify is fine. If you're like, this is a one-off animation, it's always going to play the same way. Or if you're like, I just need to hack something together really fast. But if you want to like start a project, there is no reason to use sound notify, like the old school play sound notify. And instead, I would recommend rolling your own notify scripts. Now, the caveat here is, and this is where doing some coding work can help. And you'll see that if you look at Project Lyra, I created my own notify as in C++. And the reason I did that is because I wanted to give players the ability to preview the sound selected. And so there's like a whole preview section underneath, like a drop down, like an advanced menu, and then you can add like the different libraries and try out the sound and sort of make sure that it works in context, because that's like the hard part. If you're just sending an event abstraction and you're just looking at these. You're just looking at the animation. It helps to hear something. It helps to hear it. You want to be able to hear it. So that's the only caveat is previewing. Is if you want to have previewing, then you can do that with C++. But yeah. Right. Anyway, so where are we here? We got 716. We're doing fine. Okay, we're doing all right. So in our case, we actually just want a footstep. I guess we could do left, right, but I don't really want to do left, right. So we'll just call it a footstep. And yeah, I think that's it. So we don't need any data. Right? Yeah, we're fine.
You want to sync up that
notify? We could do a chooser, huh?
You want to sync up that notify?
Yes. Yeah. But I just wanted to tweak this real quick. I'm just going to get rid of this. And I think actually we're just going to get rid of overriding this function completely. And we don't need this variable. So I'll just get rid of that. Okay, so our footstep... So let's talk about animation real quick here. Yeah, this is Dan gets to nerd out. Dan's other hobby. Okay, so the run cycle has 8 main parts. A canonical run cycle will have 8 main parts to it, which you kind of just split up into 4 main parts and just sort of swapping left and right. But you have this sort of full extension part, and you have, and then you have this part right here, which is called the passing position, which is when the legs pass each other. Now, this is really interesting because this is how animators break down the cycle. This is what's important to animators. So this is the sort of like the extreme, basically, part of the pose, where the legs are basically the farthest away that they'll ever get. And then, oops, why am I not grabbing? There we go. And then this is the passing position, is usually considered the midpoint. So if you're playing a game with like very minimalist animation, like, you know, like maybe a chip, like sort of chip 8-bit retro throwback thing, then you might just see 4 poses, which is like this, and then this, and then this. Mm-hmm. So, or I guess it would be like this. And so those might be the only 4 poses that you see. Then we have this, which is the contact position. And the contact position is from an animator's perspective, is when they start tracking across the floor. And so an animator is, I lost the handle. There we go. So the animator is going to be wanting, in this case, you know, we've got like this, it's stuck in this root position. And so we have sort of an imaginary speed for that foot crossing the floor. And ideally your animation, your like running speed will match this animation. That's part of the motion matching thing, I think, is I think there's some magic there with like footstep tracking in terms of speed and footstep speed, because you want, like, this animation is set to a certain frame rate, but we can sort of tweak it because it's a model, it's all vectors. And so we can slow it down and speed it up without losing any information. And so, yeah. Anyway, so then you have the contact, and in this particular run, it's going to be really close. But then this is the up. And you can actually see the foot in this case is actually dropping below the surface. What's supposed to happen is this should be on contact with the surface, and it should be pushing the character up. And so you can see, yeah, they're sort of. Oh, actually, sorry. This should be. Yeah. So I think. Yeah, that bothers me that it drops below. Anyway, this.
Can you hide the surface or something? I don't know.
No, I mean, it's fine. It's fine. Anyway, with the contact position, sorry. And then the next one is down, the down one. And this is where the leg bends here. And this is me you caught me. You got me. I got it mixed up here. So it's contact, and then it's down, and you can see a bend in the leg, and you can see the head drops down. And this is supposed to be the lowest position in the cycle for the head. And then we have the passing position, and then this is the up. Sorry, yes, the up, and then this is sort of the launch off. Anyway, this part, contact to the passing position, and the passing position to the up. This is it's kind of like our heel. And then our toe, heel, and then our toe. Mm-hmm. And so but in a running, when people run, so the foot's not really doing a whole lot here. But when people run, they usually don't land on their heel because it hurts. because we've got a lot of force. And so oftentimes you'll see the runners it'll be very close. Either like it'll be full foot or it'll be cushioned slightly with the toe down. And that's why if you listen to running, oftentimes you don't hear the heel part. Whereas like a walk cycle, you're going to hear it. Like if we just take a look at the walk cycle. Grab the thing. Okay, there we go. So there's our there's our extreme contact. The down is right away, and you'll see the head dip very subtly, and then we have the passing position, and then the up, and then the extreme again. And it's kind of interesting. So the timing of the down and up compared to the extreme and the passing position creates a kind of a type of feel to the walk. But anyway, so we've got contact. So that's our heel. And then the toe comes basically from the passing position to the sort of launch off here. And the ankle should be giving it some force because we should be pushing up a little bit because we're effectively pushing forward. Walking is just really fancy falling because we just like we're falling and then we put our foot in front of us to catch ourselves.
You're
and
just
then
moving the earth beneath your feet.
Well, it's I mean you're So anyway, so the heel to toe. If we wanted to split it up, I think actually walking would be a great example for that, is splitting up the heel and toe. And we've done this before on the stream where we have kind of gone to like more extremes in terms of creating variation in our footsteps. Anyway, so what we're gonna do is we're gonna tag our contact poses to keep it simple. And so I want to start from the beginning, and I want to sort of see because we can see here we're not even starting at the passing position. For whatever reason they decided to start at this spot. I think the reason was because I don't know actually, because this feels I would want to start where the leg is straight down because that's usually like the pose, like the standing pose. Yeah. But yeah, I don't know. For whatever reason, this is what they did. And so, if we were doing heel toe, this might be where we might want to start the toe this early, But anyway, we're going to do contact here, and that's our right leg. So we'll put notify there, and then we're going to look for the next one, the next contact position. And that is, that's...
So since it's 18 frames, does that mean it's probably 9 frames later?
Yes, correct. So we're basically at frame 6. So... yeah, I mean, this is where you can sort of fudge it. You can be like, I think, yeah. But yeah, we could try it here, and we'll just see how. That's another thing is sometimes you tweak them because of the sound, and this is where we're at sort of disadvantage because we're not going to be able to audition the sound. For the reasons I mentioned earlier. Okay. With that said, the other thing that we want to do is we want to double check our bones. So we want to make sure, look at the skeleton. We want, is it foot or feet? We got foot, yeah. So foot L and foot R because we're going to want to play our sounds at those spots where these bones are located, but we're also going to want to trigger our check for the material, our surface. from these spots. So foot, it's lowercase foot underscore L and lowercase foot underscore R. And so what we can do is, where's our anim notify? There we go. Okay. So in our receive notify, we're going to get our mesh component. We can get bone. Get bone.
Transform?
There we are. Yeah. Actually, I just need
just location.
Yeah, do we have just location? I think it's not a I think technically it's not a socket. Maybe it is. Maybe that'll work. But we'll get the bone transform, that's fine. We can just get the location out of that. And so that's what we could do. So let's add a variable b right, and then we'll add that to our tag so we can know if it's a right foot or a left foot, because that way we can get the correct socket. So here, this is the right, and then save it. Yeah, there we go. So now our notify, we can do one of these selects and pass the right in. And if it's false, we know we want foot underscore L. And if it's true, we want foot underscore R. And we want world, and we just split this out. So we got our location. And then we can do a trace line. We will do by channel. And this is the other thing is which could be useful is you could add like how far you want the trace to be done in the animation. Be like, maybe it's like flying or something. Who knows what? Or it's landing or something like that. But in our case, we could just start at actually, you know what? We're doing the contact position, so it's probably fine. But we saw the foot go below the surface, right? So maybe we want to start. Yeah. So we might want to start above the surface. Anyway, we can get the get owner. Sorry, get not that. Autocomplete got me. Get owner, and this will get the actor that this mesh component belongs to, and so we can ensure that we're going to ignore this actor when we do our trace. And we'll just use the visibility channel, and then we'll just do subtract, and then we'll do we'll do like a width of 50. We don't need to go that far. So I need negative 50 here. Negative 50. So 50, half a meter down, basically.
So you're subtracting negative 50?
Yeah. So this is, so this could be really interesting. Right now, I'm assuming that negative Z is down. Right? Mm-hmm. I'm assuming that. But what I could do instead is I could do something like, get up vector, right? And then multiply that by 50 or negative 50, I guess. because this will give me a normalized vector that points up, and whatever that means. And then I could do something like this. So if the actor was like upside down, walking on the ceiling or something like that, then it would detect the ceiling surface. But that's, all of this is relative, because if if the mesh is upside down and the actor is not, then maybe I'm getting the wrong, up vector. So it's all kind of relative. But so anyway, just keep this in mind. I'm just gonna do the -50.
So that's gonna be like you're subtracting -50, so you're adding 50 to your end location.
So yeah, no.
I thought it was crazy for a second.
No. Good call. Yeah, I did. I was double thinking that subtraction.
But you could have also been compensating for the foot going through the floor. So I'm like, yeah.
Yeah. No. This is the end point. So yeah, and then we can add a little debug draw to make sure that we're seeing stuff, we're getting stuff. And this actually should be sufficient. Actually, we could just do this right now. This, I think, is just like it has the notify been handled. And maybe we could do that. I don't know. Let's see. But let's just check to see if we're getting the debug draw in our. This would also double check that I've selected the correct animation to tag. Not looking good.
That doesn't look like the same animation, I don't think, right?
It doesn't. It does. I agree with you. It doesn't look like the same animation. Let's double check. So here's our animation blueprint. And if I go here, so it's definitely using... we saw it use this blend space. If I play, this is... wait, what? This is the run forward. Oh, A H U M. Okay, well, okay. Here's what we'll do. Is we'll actually look at the blueprint and see. Okay, so we've got here's our anim graph. Okay. This is the idle run. And this is, so it's this blend space is what the state machine is calling. It's feeding speed in this, and this is the blend space. And so we have, actually I want to see, okay. And so if we go into that blend space layer, we can see on the left side, this is... oh. Wait, did I just grab the... there we go. Sorry, I grabbed the wrong dot. So on one side it's yeah, this is okay. Well, this is walk forward. This is idle. Oh, I see. Sorry. Okay, and then this is run forward. So I guess AHUM walk. Can I see this? Oh, here we are. Here we are. So the blend samples here. And so we can go to that. There's idle. And we can I go back?
Doesn't it use the same editor window when you did that, or?
Yeah, but it just opened it up in the same one. So I just gotta keep referring back to this guy. Okay, so so it's the walk forward. AHUM walk forward. And where was our blend sample? Yeah, so here's the AHUM walk forward. It's this one. So here's our walk. All right. There we go. And we just need, this is one, yeah, so it's just one cycle. By the way, on Valley of the Ancient, the animators threw me for a last second change because we had a 4-step cycle for Echo when we were working on it, and then the very last minute they changed it to an 8-step cycle.
Nice.
And so there were, so it would play for 4 footstep sounds, and then it would stop and not play any footstep sounds.
Just activate stealth mode.
Anyway, so here's our walk contact. I'm not really doing a, like a proper, this is the right footstep. I'm not doing like a proper walk run distinction. So it might look a little, it like might not look great, but yeah, anyway, so there's that one. And then the run was this guy here. AHUM run forward. This one. Yeah, so we didn't tag it. So we got it threw us for a loop. We start with the left contact position. But it's just about frame 1 here. So I'm gonna do this. And then yeah, this one's 20 frames, so yeah, okay. That works. That looks good. Maybe good enough. This one's the right. Okay.
Take 2.
Take 2. Let's see. Yep, there we go. There's our little dots. Little guy. I didn't do any like lands or anything like that. We're not going to worry about that right now. How are we on time? Is this going to be like a 2-parter? Yeah, there's like 20 minutes left.
Yeah, no, I think this is a good kind of lesson in animation theory. I mean, animation's probably the discipline that I know the least about in terms of just overall knowledge.
Yeah, I kind of got in the weeds there with like talking about the animation cycles and embarrassed myself for forgetting.
I mean, that's really helpful.
I got to get back into it, man. This is part of, not having a regular day job. But let's, here's what I want to do. With the 20 minutes we have left, I want to add the surface types, and then I want to spit out a debug that says we are correctly detecting the surface types. Mm-hmm. So let's go to our project settings. And then we have, I'm just going to surface. So here is the list under engine physics, physical surfaces. Default is always there, but we want to add 4. So we want this sort of, I don't know, I'll just say stone, and then mud and grass and dirt. So go back to our project settings. Stone, dirt, grass, mud. And do I need to, once you use, yeah, I think this might be good enough. I feel like I've had to restart the project before, but maybe this will be enough.
I'm sure they already exist. You just named them.
Yeah, there they are. Yeah. Yep, they show up. Cool. So, okay. So what we're going to do is we're going to go to our anim notify, and upon success, we will we'll do a little break out the hit result. And you see this physical material. So this is where we're going to have to create, let's see, in our demo, we're going to have to create 4 physical materials. This physical material is an asset that's sort of just a data asset that describes the properties of a physical material. And it's part of the physics system. So you go under physics, and you'll see a physical material asset type. And yeah, there's a, I don't know why it's got a wizard like that. I guess you can subclass it and it'll create like its own thing. Anyway, physical material, we have stone, dirt. I'm saving with Control S, and I am duplicating with Control D. And mud. Okay. So underneath these, there's a lot of stuff where it's like, hey, someone can go in and sort of describe the coefficient, static friction coefficient for.
They're simulating, right?
Yeah, because they're simulating, right? But what we care about is under this sort of physical properties, there's a surface type, and this is the sort of project level stuff that we were talking about. So this is dirt, and let me just sort of pin this real quick. Got grass, so this is grass, mud, and then stone. Now, because I created the materials, I didn't create the art in the materials, but I created the materials because I got like an asset pack, and that it was just like, here's textures for like a complicated landscape material. And I was like, no, I just need some simple materials. But in each material, you'll see a physical material reference. And it's, I think, I'll just type it in, I guess. Physical material. Here we go. Material is what they call it. Okay. So, and you'll have a physical material mask. And so the physical material, basically this is something that needs to be updated, by the way. But the physical material mask allows you to define an exception to the physical material. So what happens is that when it does the check for the physical material on the surface, it will check the UV and it'll return either the physical material or the masked physical material. But what that means is you only get 2. and the mask is a texture. So it's not really good for dynamic stuff. Like, for example, a lot of folks do like crazy puddles and stuff like that.
Yeah.
But just sort of be aware of that. And then here we have just our, what is this? This is a stone. Oh, decided to take a second there. This is our mud. And yeah, there are engine defined, surfaces, but I just recommend for your project you just sort of roll your own, because it's very awkward when you start affecting the engine stuff. Anyway, so now let's go back to our. Now we should be able to get it. We should be getting a proper reference to the physical material now. And we're going to get surface type, because that's one of the, remember, if we look at our physical materials, surface type is just one of the parameters on our data asset. And what we're getting is just a reference to this data asset. And then we can do, in this case, we could do like a select, right? This is what, if you look at the a switch. If you look at some will do this. Some footstep tutorials will have a switch. But what we want to do is we're just going to, I think we can just get string. Here. We're going to do a fancy enum to string right now because we're just going to be calling a debug function. A print string so that we can verify that we are getting our correct surface type. So we should be getting default on all of the undefined spaces. And then we go down here. We got stone. Beautiful. We got mud. We've got grass. And we've got dirt. So, yeah, that's pretty good. I think that's good enough for now. Yeah.
That's cool.
Yeah. How's the chat? Any questions?
It makes me sad now whenever someone references Chuck Norris that they use past tense.
Right. Yeah, that's right. It doesn't bother me that much, to be honest with you.
It's end of an era,
It is an end of an era.
All the memes.
Yeah, I think the memes went to his head, so I don't know. Yeah.
So next week is going to be finishing up the chooser table implementation.
No. Next week. Next week there's a function. There's a local function.
That's right.
But we'll pick it up week after next, and we can wrap up the footstep system. We can look at I'll have some time between now and then. Who knows if I use it but maybe we'll have the actual footsteps built, and we can sort of take a look at those footsteps, and then we'll want to. I think what we'll want to do is figure out. Actually, this is where we don't have to deal with the switch, right? The switch statement, which is sort of the classic hard-coded method for and then it's always a pain in the butt when someone updates.
It does not scale well.
It doesn't scale well, yeah. And so this is where the chooser table will be like a little hero for us, because we'll pass that surface data along, and then that'll be fed into the chooser table. So yeah. It'll be a little bit of crossing boundaries. We have an anim notify that's been called from our animation, and we need to get that information back into our actual actor. But we have a reference to our actor, and so we can call a function yeah. So it'll be good. I think it'll be pretty straightforward. Might not even take 2 hours, so.
Well, we can spend the rest of the time gushing about how much time it saved us. And,
yeah. Or maybe we'll do walk and run. I don't know. We'll see. Yeah. I don't have my gamepad hooked up. It helps if you have a gamepad hooked up, then you can do variable
speed.
Yeah. But yeah, so we got pretty far. And yeah, it's pretty, yeah. Hope everyone likes it. I don't know. Yeah. Cool.
Yeah, it was good.
Happy anniversary.
Yeah. Keep it going.
Yeah, the table implementation. Yeah, the table implementation is. I think my wish list would be to be able to change the table. That'd be cool, but we're not. gonna be able to do that right now.
Well, one of these weeks I need to bring something to show and tell. It's been a while since I've.
It has been a while. Well, sorry, go ahead.
You can go ahead.
Well, I was gonna say, you know, Eric's been kicking butt on some 5.8 stuff, and so
that's right.
It's kind of exciting. I'm really looking forward to when that comes out, and excited to sort of see how people, because Eric fundamentally changed how everyone will see meta sounds forever. So
that's big hype. That's a lot of hype for a rather. It's hype.
It's like cosmetic, but it's cool, and I think that, you know, we've talked about this before, but there is this sort of like different eras of meta sounds where you look at a screen grab and you're like, oh, that looks like it's from early access days, or, you know, like you see the little marching ants, you know.
Yeah.
But I think it's another era, is, you know.
Yeah, it's turning a new chapter.
Yeah, exactly.
It is in GitHub, so if anyone wants to grab a sneak peek, go check
You know what's funny is I did grab GitHub, but I ran out of local space.
Oh no!
Because you know, during when you're compiling the whole engine, it takes up so much
disk
space
files and stuff.
Yeah. So I've actually been sort of trying to optimize my drives so that I can compile it. But yeah, that's anyway, that's a story for another day, I guess.
Yeah. So I mean, besides like anything that's 5.8, I've been playing around with mass, the mass entity system. I think it's just called mass now. I think they dropped entity from it. I don't know.
Yeah.
And state tree. So like mass and state tree, using those together. It's a bit heavy for a stream. I feel like it's a whole different realm of programming.
Yeah.
Outside of object oriented stuff. So, but
yeah, I still have those books that was it you recommended me?
The data oriented design stuff.
Yeah. This guy.
Yeah, it's a good one.
Yeah.
So if you're interested in learning, you know, data-oriented design, that's a good book. It is free online. I think it's literally just dataorienteddesign.com. Me too. So what actually happened was I ordered the book, and the next day, like I wanted to just find an article online to read, and so I just searched for data-oriented design and started reading this website. And I read pretty much the whole thing in like a day. And the next day the book arrives, and I open it, and I'm like, I just finished reading this entire book while it was on the way to my house. And,
that's funny.
But I like having hard copies. It's easier for my eyes, I think, than sitting at the screen all day. But mass is really cool. Maybe I could put together like a small little sample and show some of the code for it. But
well, you know what would be cool? I mean, this would be a lot, but like a more of a structured presentation.
Yeah.
Because I think there is a kind of like, there is a little bit of a wrapping your head around the idea first. Because like a paradigm shift. But no pressure. Also, or if you just make something that's neat and then you can show it, that's easy too. And then you can sort of like pseudocode describe what's going on.
Yeah, it helps to have like maybe a couple slides just to diagram out what because like ECS and mass, it's all about like how things connect to each other and the data, blobs of data flying around everywhere. But,
for me, the revelation was relational database. So if you ever try to if you ever worked in a relational database, organize how you organize the data and the relationships is a huge part of the scheme. And I think once you once you sort of like realize that that's basically what's going on, then I think it's very, I feel like it was very clear. Like, yeah. All right. Well, thanks everyone for joining us. Cody, Pilar, Steven, Mark, and yeah, you were the 4 holdouts. Yeah, there's only 4 people left. Thanks for everyone else who joined. Obviously, Clara was super helpful, and everyone I missed because I was focused on the other screen. And Charles, look at that. Yeah, yeah, people of the future. Angelite. Anyway, it's awesome, and yeah, thanks for hanging out with us. All right,
see you.
Bye all.